Okay, good morning, everyone. Thanks for joining. This is Randy at Central Region Headquarters. We're going to go ahead and get started with this week's guest speaker series. Today we have Andy Just from Central Region STI, Steve Fleegel, the SU at WFO Aberdeen, and myself are going to provide kind of a live weather discussion, looking at some kind of medium range tools. Some of these can be used in the short range, of course, but basically going to look through a real-time forecast discussion. You can see at the bottom there, we're going to use poll EV. So you can text RGRAM 936 to the number 22333 to join, or you can go to the website there. So you can set that up now, or it'll come up again when we get to the couple of poll questions that we have. But basically, we're going to take a look at a real-time event. These are kind of fun because we don't know the answer. I like to kind of call them a high wire act without a net. Because we don't really know what we're going to talk about when we do these things until we start talking about it based on Monday. Like, okay, what do we want to talk about this week? We really like it to be a discussion. So go ahead, Andy, maybe in advance, the next slide. We really like these to be a discussion. So, we'll pause at different points and people can interject and share ideas and that sort of thing. But today, kind of the discussion flow, and we like to kind of think of these as this is the kind of stuff that we'd be talking about, sitting around on the ops floor talking about the upcoming forecast and the kind of tools that we would be all discussing together. The best way to get good at anything, of course, is to practice it and repeatedly do it. So that's kind of why we do these and sometimes cover some of the tools that we've covered before. It's been a few months since we've done one of these. So today we're going to talk about the WPC clusters. Andy's going to talk about that, and the EFI and how to utilize those. I'll discuss the weather and context tool and how we can kind of utilize that to maybe find NBM forecasts that are climatologically anomalous very quickly. We'll go through some NBM output and some different ways to look at that. Then we're going to look at the EPS output using WeatherBell. And then Steve is going to be kind of live as we go through the presentation, creating kind of bullets and content that might go into an AFD. So he's going to be doing that kind of on the fly as we have our discussion. So I'm going to turn it over to Andy at this point, and he'll get us started.
All right, thanks, Randy, and good morning, everyone. So, one of the things with this presentation, we want to make sure that we're always keeping our Central Region roadmap in mind here. And if you go back to the roadmap, there are a couple deliverables that we have in there. The first is about this developing a baseline plan of training and delivering probabilistic forecast information. And a lot of the tools that you hear described today kind of go into that format. And we have started looking at that within our probabilistic snowfall messaging testbed, and that's all part of a broader probabilistic data infusion plan. But we also have this other deliverable about the toolkit for effective messaging and probabilistic information. And again, this is where we're tying these tools that we're going to be going through today. And in fact, to get a little bit more deeper info on these tools over the next few months, there will be a variety of vignettes released and how you can tie these tools to messaging. And we're trying to show some example here of how we can do that with our messaging as well. And then there will be an overall guidance document trying to encompass all the tools and vignettes. So the first poll question here for you today, for those that are attending, if you can answer here. So when you go and look at that medium range, what is the first thing that you look at? And there's a couple different options here, and I'll give everybody a few minutes here to respond. And there is definitely no right or wrong answer to this question. It's really just to get a kind of a sense of the, what's the state of forecasting out there for the medium range, and how you jump into it. All right. So where things are shaping up, it's actually not surprising that we have a lot of us that look at just the deterministic models, AWIPs. You're sitting there as a forecaster. That's what's easily available to you. you know, simply from the volume drop-down menu or via some procedure that you have built. So it kind of makes sense. A lot of these other items here are pretty much things that you're going to have to go off AWEFS for, minus some of the NBM stuff, which is in AWEFS as well. So thank you all for who have submitted their questions to this. So with that, I am going to move on to the next slide here. There we go. So let's take a quick look at some cluster stuff for what's coming up. And so the cluster analysis tool, as described in some previous presentations here, it's a really nice quick way to visualize all the ensemble data that we have available to us. Again, WPC runs this. You essentially group the 100 ensemble members. You know, there's 50 in the European, 30 in the GEFs, and then 20 in the Canadian ensemble. And it groups basically similarities into four clusters. There's certainly a lot more stuff that we can dig into here in the clusters, and that's a little bit the vignettes we'll go to, but we're just going to look at this from a cursory overview for the purpose of time. And so we're starting here at day 3, and so you have the 4 clusters you can see in labeled 1, 2, 3, and 4, and each one labels how much percentage of each ensemble group is in that cluster. So in cluster 1, you have predominantly a Canadian and European ensemble group here, total of about 46% of the European ensemble, 35% of the Canadian ensemble, only 3% of the GEFs. And this situation suggests a deep, some deeper trough over New England. And honestly, all the clusters have pretty much this deeper trough presence. Interestingly, the cluster 1 is a little bit weaker with this trough over Idaho and Montana. And what could be the potential ramifications of that to think about when you're going through your forecasting process. If we move along to day 4, there's actually not too much dissimilarity, and really in day 3 and day 4 you may not see a whole lot of difference in the overall 500 height patterns, but you'll definitely start to see them increase as you go out farther in time, and that's just with the nature of the way the ensembles work and uncertainty that you're going to see a lot more. You should see a lot more spread, and you can really see that here by day 6 with cluster 2, which is even a good chunk of European ensemble and a 25% of Canadian, want to hang this trough back a little bit more over Ontario, whereas you've got this deeper situation in cluster 4 heading out over the Canadian Maritimes and more brought out, slightly weaker, but maybe not as pronounced out back in Ontario and that from clusters 1 and 3. So really, again, this clusters really show you a nice spread of scenarios. I do want to kind of go back for those that were on the 9/15 Central Region Rock, the Rock field ops briefing. There, we've had a highlight from WPC about the threat for heavy rainfall over the Ohio Valley for this weekend. And if you actually look at this 500 height pattern, you can kind of infer that there's probably going to be an upper jet streak situated on the southwest side of this upper trough over Ohio, West Virginia, that general area, which would put the Ohio Valley and back towards Missouri in the right entrance region. Let's zoom in a little bit on these clusters, and I'm going to go to 24-hour QPF. And here it's kind of neat to see how the slight differences in the ensemble suite and from the 500 height pattern and other factors thermodynamically and all that impact how the QPF field will align. There's certainly a good agreement here amongst all the ensembles of this heavier band of some QPF. You've got many of these clusters producing over an inch of rain in the I guess that'd be for the mean out of each ensemble cluster group. But there's definitely some differences in terms of how far east that maxima is. Take the cluster 1, which is back over Kansas City. Cluster 3 is Missouri to Kentucky. Cluster 4 is more in Kentucky, and cluster 2 is more into Kentucky. Cluster 4 is there in Indiana. So again, just kind of unique. It's again all showing slight differences in thermodynamics, and the synoptic pattern can result in quite a bit of difference on the resulting QPF pattern. And of course, we're getting a convective season, so that's playing a role here as well. Just want to show that. So one index I personally really like is this ECMWF Extreme Forecast Index and Shift of Tails. And these are just a really nice situational awareness display from the European ensemble only on where there are extremes relative to the model climatology. And you kind of have to use both of these together, because the EFI is going to give you just general, okay, this is an extreme and it's going to be confined to probably 0 to 1, but it's not going to give you how extreme that event could be. And that is where the shift of tails come in. And we'll kind of do, and I'll kind of be able to demonstrate that here through some examples. So looks like I had the wrong, I'll change the link up. So this is the EFI table, and this is how it will always load up for you when you go to the site. And it starts off as a CONUS region, and we're going to leave it as CONUS just for this case. And we kind of looked at this during the weekend time frame, based again on what the quick glance from WPC thresholds. So this is Friday night and Saturday, looking at QPF. Not too much here to note back over the Ohio Valley, but there definitely is a presence back up over Rapid Cities area up to Glasgow and that. Let's jump ahead to Saturday night and Sunday, and definitely an area stands out to you here over Missouri to Kentucky. Now the EFI values aren't super extreme. You think back to the sometimes during the winter months, even into the spring, you would see these QPF things hitting all the way up to 1. And I think this is just a function now that, hey, we're getting into a time of the year where it's more typical to have heavier QPF events. So, but at least from this, you get to see that, hey, we're starting to see a lot more of the European ensembles suggesting some heavier QPF. And it's certainly the 0 highlight here has got some suggestion that there could be some a little bit higher value members. So let me go back to the presentation and go to the EFICDF data. So this is something I've been wanting to share for a while. This is off the ECMWF open charts page. So this is online. Everybody can access this. There's a point-based products option. If we go to the EFICDF, you just type in a city here. So somewhere in that, if we go back to this EFI area, we'll pick, and since we'll actually talk about it a little bit later, we'll take Evansville, Indiana here just as a site. And so just type that in. Oops. If I can type, yeah, you'll see it's like everywhere. So the default when you load this is it's going to give you the first 24 hours for the valid time. So let's jump ahead to the time period where that EFI was highlighted over the Evansville, Indiana. And so this is the actual EFI up top. So to kind of visualize the EFI, the black line here, consider that is, okay, that is the model normal. The purple line here is the last forecast here for the EFI. The red line is the newest one. So the red line is the one that we're seeing on the website. And you'll note that the EFI is essentially computed by taking the area between the normal curve, the black one, and the forecast one, which in this case would be the red. And so the farther and farther that red that these lines, purple, red, get away from the black line, to the right, you're going to increase that EFI value. So that based on where it is right now, the EFI is situated up near 0.75. That shift of tails that was up around 0, that's that looking at the top 10%. And you can see that there are a few members of the European ensemble that are suggesting all the way up to like 60, 60 millimeters, which would be a couple inches or so of rainfall. So that's really, if you want to dig down into the EFI and what's this actually look like in a graph, here you go from the ECMWF Open Charts page. All right, I'm going to send this back to Randy.
Thanks, Andy. Any comments or questions from anybody out there? Feel free to type stuff into the chat or questions pane at any time, and we can address this as we go through. But I'll pause here for just a moment to see if anybody wants to raise their hand. You can do that, or type in the questions pane if there's something you want to discuss or ask. Okay, nothing seen. So let's move on to the weather and context tool. The weather and context tool was developed, I believe, via national Sioux team. It was put together. Tommy Graffenauer, the Sioux up in Grand Forks, was our Central Region representative. And I really like the weather and context tool. It's a great way to quickly see if you have something anomalous in the NBM forecast relative to climatology. So as you can see on the right, there's a table option, and then when you click on the different cells, just like you do with the anomaly situation awareness table, it brings up plan view maps. They provide you more detail. So what it really does is it highlights locations that are forecast to approach, meet, or exceed daily record values. That's one thing I want to point out. This is a daily record value table, so it's a little different than looking at, say, 24-hour QPF. From the NBM, which is depending on when you're looking at it, is going to be 0 to 0 or 12 to 12Z, et cetera. This is going to be based on daily values. So, but it's a really quick and easy way to find forecasts of interest. The available fields for both the NDFD and NBM in the weather and context table are the record high, max T, high min T, minimum record max T, and of course the minimum temperature records, and then record daily QPF. So those are the fields of interest. And one thing that's really nice about it is this is, just shows real sensible weather very quickly. Might highlight an area that you need to investigate more deeply in the NBM. So let's go ahead and advance, Andy. So I wanted to go through the table real quick just to kind of explain the color code. And this is available when you load up the website. You'll see the tables on the far right will show up on the screen when you first load it. But the nice thing is the color coded cells quickly let you know how many ThreadX sites, so it's only ThreadX sites that are available in the weather and context tool, are forecast to exceed or approach those daily record values. And so what you see is in the temperature columns, the left number highlights the number of sites forecast to break records, and the right number represents sites forecast to be within 4 degrees of the record. So that's there, and the arrow points to Monday the 3rd. That means you have one site exceeding record values and 37 within 4 degrees of their record high. If you click advance, Andy, that'll bring up another arrow pointing to the high min category. When you see a red cell, that means there's 31 to 50 max or high mins in this example. So 39 record high minimums and 92 within 4 degrees. And then finally advance one more time, the QPF column, you'll see there's a table there in the lower right that the cyan is more than 50 24-hour precipitation records. In this case, there's a 1 to 5 highlighted. In the QPF column, the left number is sites forecast to break records, and the right number is sites to forecast to be within 50% of the record QPF. So in this example, one site breaking a record, 11 sites within 50% of the record. So go ahead and advance, Andy. And then when you click on one of those cells in that table, then it brings up the plan view. And I just have a couple examples here. One from a high max, a record high temperatures example. And you can see on the right how it just color codes the varying shades of red to maroon based on whether you're forecast to break the record high, within tie it 1 degree, 2 degree, etc. And so that's the different colors that you see in that upper right image. And in the lower right, you can see the QPF values. The cyan is 150% of record precipitation. And then the really light green will be within 50%. So that's kind of the color coding that you'll see on those. And when you click on the individual numbers or precipitation values or temperature values, it shows you what the record value is. So it's really easy to see what the record QPF is and what the forecast is right alongside it. So let's go ahead and advance, Andy. And so I want to show you kind of what the forecast was like for this upcoming weekend. And so this is from May 3rd, 0Z run. And you can see that there was, at that time, for Sunday, there was 2 sites forecast to exceed record values and 23 within 50%. Paducah, there was the 1.58, which is well above their daily record value for Sunday the 9th. And then you can see Evansville is at 1.54 there was the forecast. So go ahead and advance, Andy. And then the next forecast on the 4th is 0Z. Evansville is 1.11. So the forecast from the NBM deterministic, this is the NBM deterministic run, by the way, decreased to 1.11, and Paducah is down to 0.84. So go ahead and advance one more time, Andy, and let's load up today's table, and we'll kind of look at this a little bit. And so we're going to switch to the NBM forecast and view the table. And we'll see that there's 4, let's go to Sunday, 4 exceeding record values and 21 within 50%. So you can see Paducah is exceeding their record values at 1.16. Evansville is at 1.42, which is a protein. So let's go ahead and we're gonna take a look at a violin plot for Evansville, and we're gonna look at the distribution of the ensemble members. So we're going to click on the 1.42 there, and you can see this. I love these violin plots that are available on Weather and Context because it shows you what the record precip value is in the blue star, what the WPC forecast is, and then you can see the NBM deterministic forecast. They're just shy of 1.5 inches at 1.42 inches. And this was interesting. It's kind of got a bimodal distribution where you see it's pretty heavily weighted down below 1/2 inch. The 50th percentile is right at 1/2 inch pretty much. And then you kind of have the secondary maximum up at, say, 1.75 inches or something like that. So this is really interesting because it gives you an idea where the deterministic NBM forecast falls relative to this particular ensemble distribution. So I just kind of wanted to point this out to note the 50th percentile here is about 1/2 inch because we're going to look at some NBM output. And what you'll see is that it's different. So, this is not the NBM membership that we're looking at when we're looking at the Weather and Context tool. It's got its own ensemble membership. So this is an interesting forecast, and what you see here is the NBM is on the higher end of the distribution, clearly, probably up around the 75th, somewhere around there probably, of the distribution of this particular ensemble output. So let's go back to the presentation, Andy, and go forward. And I want to just touch real quickly on the Weather and Context membership. The NBM has like 170 plus QPF members in the short term, and into the medium range. It has a huge membership. This Weather and Context has 44 members that I have listed here. It's a CMC control, 20 bias corrected members of the CMC. There's bias corrected membership on the max T, min T, of course, and then non-bias corrected for the QPF. But it's basically a CMC control, 20 CMC ensemble members, the GEF control, 20 GEF ensemble members, the NDFD and the NBM. So you have 44 members. So there's far fewer members in the Weather and Context pool. Just be aware of that. And I just want to point out, I don't expect anybody to remember this. Just be aware that when you look at the Weather and Context tool, if you ever wonder why the 50th percentile is so different from the NBM 50th percentiles, because they're not the same ensemble. And also you're looking at daily values, and where in the NBM you might be looking at 0Z to 0Z or 12Z to 12Z, depending on what run you're looking at. So that's all I wanted to say about Weather and Context. I think it's a great tool. It's a great situation awareness tool to look at. I love to look at it early when I go through the forecast process and just see it immediately tells me if there's something anomalous being forecast in the NBM that you need to investigate further. So go ahead, one more. I think we're going on an NBM at this point. So any comments or questions, or anybody want to share their experiences with this tool or anything like that?
Hey, Randy, this is Andy. I just want to make a quick comment, and we've talked about the membership and how the percentiles are all calculated. I know there's a lot of different data sets out there that are calculating percentiles. How it's done here in Weather and Context. You had the PWPF that you have from WPC and what you produce in AWEPS. There's a PQPF. The NBM has got its own how its percentiles are computed given the different membership, and then how you might use model certainty in AWEPS, and that's going to differ. So percentiles are all relative to the data set that you're using. So just always keep that in mind. If you're mentioning like a 75th percentile, you may have to add, okay, it was the 75th percentile of the NBM or the WPC provided ensemble.
Yeah, great point, Andy. So we did have a request for the cluster analysis link, so I just added that to the chat. So let's go ahead and move forward, Andy, to the next slide. And I didn't want to, so this, you may have, you may get the sense from looking at the EFI and the weather and context tool that there's a potential for some heavy rain. That it's on the higher end of normal and maybe approaching some daily record values at locations across southern Indiana, southern Illinois, and western Kentucky. So of course, we just wanted to throw this in there that of course you're going to look at other things, right, and not just rely on those forecasts to talk about impacts. And you can consider impacts from that precipitation. Of course, you're going to look at things like the antecedent soil moisture and that sort of thing if you're concerned about flooding potential or what have you. And in this case, it is not really any issues as far as having really high soil moisture going into this event this upcoming weekend. So now we're going to move on and talk a little bit about the NBM. I just wanted to put that in there to just acknowledge that you're going to not just be looking at this output, but you're also going to be considering antecedent conditions when you're looking at heavy rain events. So we wanted to talk about the NBM QPF, and there was a lot of comments this last fall and over the winter about how high the NBM QPF was relative, for example, to the 50th percentile or the median of the NBM output. And that's because it was using what's called the grand ensemble mean. And the grand ensemble mean was something that was designed to have neutral bias on higher end amount for IDSS purposes. It was really designed as kind of an IDSS QPF as a way to communicate high end potential. And so it was not at all uncommon to see the NBM deterministic QPF exceed the 75th or 90th percentile of the NBM inputs. That changed in late March. And so what you see in the first bullet is how NBM QPF is now calculated. It's the deterministic QPF is the NBM median, the 50th percentile, plus the grand ensemble, which means heavy, divided by 2. And so it's just to show that the NBM deterministic QPF is not just taking the 50th percentile. It's the median and the grand ensemble divided by 2. And so what you see, this mitigates the high amounts that we saw with the GEM, so it brings it down. It doesn't have that. It proves the bias for lower end QPFs, but it also lowers the POD on the high end QPF events, especially in the extended. But now what we're seeing is you can really kind of expect the deterministic QPF to frequently fall within the 50th to 70th percentile of the NBM distribution. So that's where it's supposed to be based on the way the deterministic QPF is calculated. So that's why when you look at like the 1D viewer, you'll very, very frequently see the deterministic QPF be up towards the 50th or above the 50th, pretty much always above the 50th, right? It's going to always be above the 50th and often pushing towards the 75th. So that's why you see what you see when you go to the 1D viewer and look at it on the What's Up page. So let's go ahead, Andy, and look at this particular event, and we'll talk a little bit about the QPF. But first, we wanted to do another poll. So when you think of the 90th percentile in the NBM output, which of the options below, which of the options below is not correct? You probably can't select. I think, let's do this way. So type in all of the ones, all of them. Okay, so all of the ones that you think are correct. So you can submit multiple times. I'm just curious. You have to read, there's a bunch of options there. Yeah, this is good. Okay, that's perfect. We just didn't want to. I just didn't want to see any D's. So all the answers are correct except for D. So it's a 10% chance that the value will be exceeded, 90% chance it won't be exceeded, 10% probability of exceedance, and it's a high-end estimate. Are all correct answers. The only one that doesn't work is the 90% chance the value will be exceeded. So let's go ahead and move forward, Andy, and we're going to look a little bit at some of the NBM output. So we're going to start with the What's Up viewer, and we're going to start with the percentiles and talk a little bit about percentiles. So we're going to look at 0Z Monday, 24-hour PQPF. I'll give Andy a second to load this up.
So I just wanted to show that again, what we've defaulted here, load in, this is just the mean 24-hour QPF. So now we'll switch it over to the probability. All right.
Okay, so let's go ahead and look at so this is the 50th percentile for the 24-hour QPF, and you can see it, Evansville, and if you want to show her that Evansville is 0.95 there. And so you can see this is obviously not the same value that we saw in the weather context tool. The times are different, and it's a different ensemble, right? So you're not going to see the same value. So let's go ahead and look at the 25th percentile, and we'll kind of look at what the range in this forecast is. And I haven't actually looked at this run, so we're looking at it together here. So the 25th percentile is 0.35. So that's what you're going to have a 75% chance of exceeding that value. Let's look at the 50th. Is really increased in recent runs all the way up to what was it, point?
Yeah. Yeah, we got
0.95.
0.95 of 50th.
Yeah, and then the 75th is 1.64. So you have a really large range, right, between the 25th and the 75th in this example, 35 hundredths to 1.6 inches there. So if you're going to communicate this, right, that's a really big range. If you're going to communicate ranges, like especially like when you think about snowfall events in the cool season, you really have to provide context, right? And if you're providing maps of say, like we provide the PWPF and you have the 90th percentile, of course, not everybody in your CWA is going to get the 90th percentile typically, right? That's a high end forecast for each individual point. So you have to provide proper context. For example, if you were going to provide percentile information in this particular forecast, I would say 35 hundredths to 1.6 inches. If you put those side to side, you know, people are going to think that's just a huge range, but you can provide context of why that is the case. You know, if the frontal boundary settles here, we're going to get this higher end amount, for example, or the moisture return is faster. You have to provide some context for the people as opposed to just giving them these huge ranges. So that's one thing to keep in mind. And another item I would bring up too is that you don't always have to provide, the high end. A lot of times you want to provide the range of potential scenarios, right? But in some events, it doesn't make sense to do that. So say you have an event where your 25th percentile is 0.10 of an inch of precipitation, and your 90th percentile is, you know, 1/4 inch. You know, what's the point, right? There's really no value in providing the full range there unless you it's going to have an impact of some sort. Like if it's freezing precipitation, then maybe that's something you would want to communicate. But for a rainfall event, that's such a minor amount. You may not need to convey specifically the 90th percentile, and just using the 25/75th is going to be plenty sufficient, and you don't need to provide a lot of context in that scenario because the difference is so small. Let's go look at the probability of exceedance, Andy. So that's one of the challenges with using the 90th percentile is it tends to bias, you know, obviously high. And if you do like snowfall, people think like, oh my God, this is Armageddon. This huge snowfall amounts all over, you know, southern, you know, Michigan or whatever. But it's appropriate a lot of times, I think, to use probability of exceedance instead of the 90th percentile. 90th percentile is especially valuable for point forecasts. When you provide them on an aerial display, it can be kind of misleading. So let's look at 1/2 inch here, Andy, for 24 hours ending 0Z Monday. And so here's a real example where you could provide some real good information to your public and your partners that, you know, there's about a 60 to 70% chance that you're going to receive 1/2 inch of QPF in that 24-hour period across southern Indiana. And it's so much more valuable to be able to say that than to say that there's, say, you know, 1/2 inch is possible, right? You can actually put a number to it. So let's go to 1 inch, Andy. And so say 1 inch is a significant threshold. Say you have antecedent conditions as such that 1 inch of rain might cause some problems. You can actually say that there's a 40 to 50% chance of receiving at least 1 inch of rain across southern Indiana in that 24-hour period. And you can put a percentage to it instead of saying it's probable or there's a chance, because those terms mean different things to different people. Not everybody interprets the word likely the same or chance the same. And so this really gives you an opportunity to put a number to the probability of exceedance. So to a specific forecast value. And social science says that this is the best way to handle things. People don't interpret words the same way, and having the number alongside it is really valuable. So let's go ahead. Any comments, any discussion? Anybody from the field want to discuss how they utilize probability of exceedance or the percentiles or anything like that? See, Jim speaking. I'm going to unmute you. You got your hand up.
All right. Hopefully you can hear me okay. Can you, Randy?
Sound good.
Okay. So if you go back to the probability or the percentiles, I'm sorry, and then double click on 50% so it locks it in. What I like to do is use that delta T at the bottom. It's just a tiny little delta T. Yeah. And so this, you can go back 72 hours in time and see the trend of how things have trended as far as the QPF for that 24-hour period. And if you start at 72 hours and then work your way back up to 0 hours or the current forecast, you can see that the amount of QPF has definitely increased.
Sorry, I got it straight.
No worries, no worries.
Keyboard button. So yeah, 72, it's 0.08, 48, 0.38, 24, 0.64, and now 0.95.
Yeah, so that would give you confidence too, not only with just amounts like you were talking about, Randy, but just thinking again of, you know, probability of precipitation and what your pop is for Sunday. And obviously there's a lot of outdoor plans on Sunday. It's you know, it's Mother's Day. I've already gotten a couple of calls in the office about, you know, people trying to make, you know, go, no-go decisions on Wednesday for Sunday plans. So that's just one way that I like to use it too, is that delta T.
Yeah, thanks, Jim. I love that. You know, it's really tempting, and there's been a long history of folks, you know, the trend is your friend looking at deterministic models, but that's not really true necessarily. I feel a lot better when you see a trend with 170 ensemble members. Then obviously you're not going to be able to do the same kind of analysis using an individual GFS or ECMWF deterministic ground. It doesn't make nearly as much sense and can lead you the wrong way for sure. So that thanks for bringing that up, Jim. That's a great use of the page. There's lots of little hidden tools and nuggets on this viewer and the 1D viewer, I feel like. Any other comments or anything that anybody wants to share or questions? Okay, Andy, let's go ahead and, before we go to the 1D, why don't you go to the next slide and then we'll come back to the 1D viewer. So this was a chart from a paper from Linhart et al. In NWA Journal of Operational Meteorology. I think it was last year, 2020. And they looked at how people interpret words of estimated probability for chances of precipitation, for example. And what you can see is that if you look at the bottom one, it kind of blows you away when you look at chance, may, possible, expected. What you notice is that they're all bimodal. Some are trimodal, but they all have a bump around 50%, right? So when you use possible or chance, some people think that chance is it really can be anything from, people interpret it from 5 to say 30%, and then there's a secondary maximum at 50%. So when you say the word chance, and we have a very specific percentage range for chance in the National Weather Service, right? So, but that's not how people interpret it. And so without the number alongside it, just using the word chance or the word possible, et cetera, in a weather graphic or a tweet or something like that, it's going to be interpreted many different ways. And I think that's why when you look at like the probability of exceedance, and you can say there's a 40 to 50% chance or whatever of exceeding 1 inch across southern Indiana from this period to this period, it doesn't just leave the word open to interpretation. You put the percentage with it, and there's going to be a lot of more discussion coming out about this and how we can leverage those values, such as in the probability of exceedance, to communicate more effectively, so that we don't leave it open to user interpretation. So let's go ahead and do the 1D viewer, Andy, and then we'll kind of start moving towards the end here. So one thing I wanted to show on the 1D viewer for Evansville is we're going to look down at the 24-hour QPF. And I just wanted to point out, if you look at the black dot, that's the deterministic run. And you can see in the box and whisker plot there on the Monday ending at 0Z, or wait, these are 12Z to 12Z, I think, this time of day. Ending Monday 12Z, that dot is right at about the 70th, just below the 75th percentile there on Sunday. Yeah, there you go. Another thing that I think is interesting is you can see that the tail of 90th percentile extends all the way up to 1.6, but the 25th percentile, the bottom of the box, is down like around 10 hundredths. So this just an interesting look that you have a pretty, you have some some outliers or some really high end amounts, but most of the membership is 4/10 or less, or half the members are 4/10 or less. So let's go to the last slide, Andy, unless there was something you wanted to add. I know you look at this all the time when you're the 1D viewer.
Yeah, I just want to use this as it's a great tool to see what makes a QPF forecast so hard to do a single, that we have to provide as part of NDFD is to put a QPF in here. But when you see these kind of spreads, and these spreads are influenced because of the synoptic and convective type evolution, it's better off to do either some sort of range or probability of exceedance or something like that. Again, I think that's what I like about this stuff, is it really shows how complex it is to actually provide a single value for a QPF forecast.
Yeah,
hey, Andy, Steve. Oh, can I chime in real quick, or have you show something?
Sure. Yeah, go ahead, Steve.
Yeah, Andy, if you scroll up just a touch on this page, one of the things I like to use, and it ties into what Jim had mentioned, you guys had mentioned earlier, if you scroll all the way up to the top and click the little kind of chart button, Yep, that one. That's one thing I like to use too, when you can adjust, like if we adjust that precipitation to, like a 24-hour, and you have, an event where they have a certain threshold that they, are concerned about for a DSS event, or, that type of thing. You can see a lot of those similar probability of exceedance values, like Randy was showing on the What's Up viewer too. So just another kind of tool. It's a little hidden there. Sometimes it's easy to forget, but I like to use that one too a lot.
Yeah, that's a great point, Steve. I love this for, like, just what you're saying. If you have a known threshold that a partner has, this is a fantastic tool to look at that for that location. And then we have quite a few Western Region people on today, and a hat tip to the folks in Western Region that developed this 1D viewer, because it's fantastic. So let's go ahead, Andy, and move to I think my last slide, which is, there you go. So there's some really interesting research. Joe Rittberger and this group from the National Institute for Risk and Resilience, or National Institute for Risk and Resilience, had a double risk in there, looked at over 300 different studies about risk and uncertainty communication using probabilistic information. And you're going to be hearing a lot more about this. We're going to be talking about this stuff for years. I've like to comment that our move to sharing more probabilistic information is an evolution, not a revolution. It's going to take time. It's going to take a lot of practice. It's going to take our ability to interpret this output. Will improve over time, and how we communicate it will improve over time. But there's a ton of research, a ton of social science research across many, many disciplines, whether it be health, whether it be emergency response, et cetera, that really emphasizes that sharing probabilistic information is much more effective than sharing deterministic information. One good example I can give is there was a study that was looking at decision when to salt roads, and this was lay people; these weren't experts, and that were taking this information in, and they provided them different types of forecasts. They provided them different deterministic forecasts. They provided them probabilistic forecasts. They gave them odds ratios, et cetera. And there was a certain risk, or certain threshold, I should say, that at which point it made sense monetarily for a DOT to salt. And when they gave the folks probabilistic information, they made better decisions than when they had deterministic information. And the number one recommendation, based on all this work in lit review that Rittberger and the group did, their number one recommendation was use probability information in place of deterministic statements in forecasts. For example, replace these storms will cause heavy downpours and flooding with there is an extremely high 90% chance that these storms will cause heavy downpours and flooding. So again, you're pairing a term extremely high with an actual value, 90%. And 90% is easy to interpret. People understand percentages. We use them in our POPs all the time, of course, and people understand what a 90% chance is versus will cause, or medium confidence. We put in graphics sometimes, like what is medium confidence? But if you can put percentages with the words, and you say likely 70%, you put that number with the word, it's much more effective, and it takes the error bars that they're putting around their own interpretation based on the word, because you've given them a value. So I'm going to stop there, and we're going to move on. I think we have one more section, and then we'll get, I think, Andy, you're going to look at some EPS stuff real quick, right?
Yep. Mm-hmm. All right, so for those of you that look kind of at weather bell graphics, I did grab some couple of screen captures here for Evansville, since we've talked about the site here previously. And this is kind of neat. It kind of goes along with what we saw out of the NBM output even. If we pay particular attention, I'm just looking at 24-hour QPF. You can also do total QPF, but total QPF kind of gets distorted because there's a few events, lighter events here early on. But if we look at the weekend, you can see that amongst the European ensemble members, there are quite a few that, if we go to yesterday's run, that were, just a couple tenths at most of total, QPF in a 24-hour window. Meanwhile, there were a few too that were on the extreme range, more towards 3 inches. One thing you'll note that if you look now at the European ensemble, so 12 hours later, which is on the right, you'll note that the number of members of producing heavier QPF, something over the, say, 2 inches, have definitely increased. And as such, you can see that the percentiles, which is down below the 25th and 75th on the box and whiskers, have definitely moved up higher in the graph. I will say the graph ranges are slightly different between the two, but you can definitely see that there is a definite increase to the values. The deterministic is actually shown on here as well, which is actually one of the extreme members of the set. So, it's just really interesting, and this is again just showing how difficult it is to nail down an actual QPF forecast for a single value, and that and why this goes along with what Randy just talked about, why a probabilistic is probably the way to it's probably, yeah, there you go, the way to have to deliver something like QPF. And we kind of already do that in our pop forecast. Pop is a percentage chance of greater than a 100th of an inch. So it's just expanding it to higher levels of QPF. All right. So pass it over to Steve.
Thanks, Andy. So yeah, what I kind of did here is just took some notes overall as things were going through, and that really kind of matches my AFD workflow. One of the things I'll suggest to people, if you want to get a little more used to looking at all these different tools, and a thing that I've really had success with is just set each one of those items up as like one of your startup tabs when you get, open up your browser at work or on a telework shift or that type of stuff. Because then that kind of forces me to walk through and step through each one of these tools. And so usually when I'm, doing the forecast process, short-term, long-term, any of that type of stuff, I'll bring up my browser, even a lot of times before I even dig into a lot of the AWIP stuff, and I'll just step through these tools, open up a worked AFD text file, and just kind of take notes. And that's kind of what I did here is, as Andy and Randy were kind of talking about different things, I was just taking notes on some of the things that they had. And so then that way, when I, looked at a lot of this stuff, I can remember some of the key features that I saw. And, some of the things that really kind of stood out to me, I'm not going to, read through each one of these, but, some of the larger scale features like Andy was showing earlier on with the WPC cluster tool really didn't show a whole lot of, differences between the overall model members on the larger scale pattern. So that kind of gives you that confidence, or at least builds a little bit of the confidence on the overall idea of the system is similar. It's just more of the subtle, smaller details. Maybe it's more convective, like Randy had mentioned. Maybe it's a location difference on whether it's the surface low or the warm front, or that type of thing. And that's things that you can dig into a little bit more as you go through. But that kind of was one thing that stood out, and especially like Andy had shown with the the QPF differences. The general idea for that central Mississippi Valley, Ohio River Valley area were that you're going to get rain in that area. It's just trying to figure out those subtle differences, which in this case is kind of a day 4, day 5 type forecast. You don't want to get too much into the details or weeds on that. So kind of the similar thing with the EFI. That was kind of some of the big takeaways, is that it was highlighting that there was this area corridor that that matched up with seeing some higher end precipitation values, even a few that were kind of showing some higher end values up over 2 inches in that area. When Andy kind of dug a little deeper into the CDF plots. For the weather and context, that's one that I'm still getting used to. But the big thing that I took away from that, and that you can kind of highlight, and it ties in with the clustering and the EFI stuff, is overall the aerial coverage with time and trends, as Randy kind of showed that through, really ended up being fairly similar. It was just the amounts that were kind of changing. So that again, kind of tying into the AFD, you can kind of reinforce that, the confidence is pretty high overall that, we're going to see the precipitation. We just, don't know the amounts at this point. But, there is the potential that we could see some records broken. Like there was, Randy had shown there's about 9 daily records that had the potential to be broken. A couple locations that had occasionally been bouncing above that 150% of the record value, which was, to me kind of stands out there too. Then too, looking at the details, seeing some of the violin plots that Randy had shown, seeing that spread, and I think that helps just reinforce that uncertainty on the QPF amounts or how much precipitation is going to fall with this event, just because he had that bimodal distribution. Definitely some weighting, at least in that smaller ensemble membership, in the lower end, generally below a ½ inch, but you also had that kind of cluster that was up towards, some of those record values that we were seeing. So, all those type of things can kind of tie into, a summarized AFD from these details that you're seeing. And then, NBM output and, the ECMWF control QPF at the end, I thought some of those things were pretty interesting. And the NBM output is some items that you can kind of start to tie into the messaging, like Randy was saying. I highlighted, that probability of ½ inch of rain, probability of 1 inch of rain, reinforcing that, there's I hate to use the word chance since Randy said we're not supposed to use chance, type of thing, or it's tough to say, but, there's a decent potential, I guess, of seeing, some, ½ inch or 1 inch of rain from this event overall. And like Jim had kind of highlighted that 50 percentile trends are really increasing over the last 3 days, and that, again, building your confidence in that. One key thing that I thought was interesting, like Andy pointed out, is where that ECMWF control QPF was located at with respect to the rest of the ensemble members. That's one thing I look at a lot here, especially the winter time, trying to get a handle on snowfall amounts and that type of thing. Seeing where that's at can help, I guess, help you understand where that deterministic value is located with respect to the rest of the ensembles, because it's easy, like was mentioned earlier on, it's easy to take a look at some of that stuff in AWIPS. And you don't want to get yourself locked into, those 3-4 models that we're seeing in AWIPS, and it just gives you that perspective of where that QPF is at. So with that, Andy, if you want to bump to the next slide. So I just kind of, just to give some thoughts or ideas for messaging ideas, social media posts or sharing with your partners. The one in the upper left, I just threw together quickly. We had done something similar a couple months ago. Using the What's Up viewer data, I just focused it more on a regional scale, but just kind of applying that probability of a ½ inch of rain to your messaging. And I didn't tweak some of the values. You can go into the What's Up viewer and adjust the size of the points and some of those things to make it a little bit easier. But it was just something I kind of quickly put together this morning to kind of tie into that. And the other one is an example of one that we used back in March. This was a case where we utilized the model certainty tool since it was a little closer in time. One of the tough parts with the model certainty tool is we only have a limited data set in the extended period that can go into the probabilities. But as you get into the nearer term, that model set is increasing. It's still not quite the level of what we get in the NBM, but it's, it helps give you a little bit better idea on some of the probabilities. So we kind of highlighted some different probabilities there, in addition to what our kind of going forecast was for that event. So that is just a couple examples of potential ways that you can message some of this information in addition to putting some of that information in the AFD.
Thanks, Steve. And I'm going to just wrap up here and say that a lot of these tools that we have shown here today, they're all on our STI Google site page. And Jim Stephen and others have done an awesome job here putting up that page together. And in fact, we just got thanks to Jim here during the talk, we got that that EFI, so you can see the CDF stuff added here as well. So you can always refer to this, and we'll probably get some of those like vignettes and other training things related to these various tools up on this page. So that's all we have for the talk today. Randy, do you want to end with anything here?